Hello everyone. How many of you checked your smartphone today in the morning, right after waking up from bed? Or let's say within the first 10 to 15 minutes. Can you people raise your hands? Okay. Almost everyone, right? Mobile phones, when invented in the year 1970s, started with a normal voice calling facility. But today, in our smartphone, have advanced features like high resolution screen with a good quality display, internet connectivity, Wi-Fi and Bluetooth, good quality RAM storage, and many more such features. Not only that, in the advanced smartphone, we have innovative features of artificial intelligence like circle to search, where a person can draw a circle over an object to initiate a search operation, automatic call screening facility to detect spam calls, filter out the calls, and many more such features. So it's quite evident that these electronic devices like laptops, smartphones, smartwatches are becoming an integral part of our daily lives. Not only electronic devices, even the generative AI models like ChatGPT has brought the knowledge to our fingertips because they are trained on a large amounts of data set, which require specialized hardware resources. Even the cars what we are driving today has technologies like ADAS technology, lane detection system, automatic emergency braking to reduce the human error. So it clearly shows that the technology has evolved quite a lot over the past few decades. So the most important point or the most fascinating point here is that there is a single technology which binded all this technology together. Or you can say there is a common thread between all this technology. And that technology is called as a VLSI or semiconductor technology. VLSI, in simple terms, stands for very large scale integration, which means millions of transistors need to be integrated to form an integrated circuit, and that circuit needs to be realized into an hardware. Now, what is a transistor? The transistor you can think of as like a basic element or the minute element in a semiconductor device, which is a switching circuitry, similar to what you people use switches in your electrical home appliances. So in this process of integration, we need to take care of three parameters, that is power, speed, and area. So the power consumption of any device should be low. Now why it is important? Let's say if you are using your smartphone or laptop, if it's getting frequently heated up, that's a problem, right? So that's why the power consumption of the device should be low. The area requirement should be optimal, or let's say the minimal area will also do. Why? Because within the smaller set of area, if we're able to fit in more transistors, it will give birth to more innovation and new features. So our today's smartphone, laptops, these electronic devices are capable of handling more features. It's only because of this VLSI technology, because it's able to accommodate more number of transistors. And obviously, the speed should be fast. There should be no compromise on the speed because the efficiency will get lost then. So let's look at this picture. Can anyone tell me what this picture is all about? So this is the picture of world's first 5 MB hard drive, invented in the year 1956. So now you can imagine how much bulky a device looked like during those days. Moreover, it's power hungry. The power consumption is very, very high. And the usage for these devices, like the storage capacity, is very limited. So now I think you can appreciate the transformative changes VLSI has brought to this world, because even more storage capacity is been fitted into a pocket-sized smartphone. The quality of the processor has been improved in your laptops, even with high-end graphics. And due to that, VLSI has provided innovations in the field of central processing unit, automotive sectors, then in your data center, servers, and even nowadays used in the rocket propulsion systems. But to cultivate creativity and to foster innovation, we need to correctly depict the inflection point. What does it mean? It means that newer technology or newer innovation can only happen at the inter-cross-section point of multiple different technologies. One of this technology is artificial intelligence. But today's artificial intelligence is like artificial narrow intelligence, or we can call it as a weak AI, because it's able to perform only an automated task or the task in which it has been trained on, but lacks general consciousness and human reasoning abilities. So the basic question here is that how we can leverage this artificial narrow intelligence to boost the impact of semiconductor devices. Because as we know, this artificial intelligence has already disrupted multiple industries like healthcare, education, finance, and technology. So in VLSI industry or in semiconductor industry, while we are verifying a product, mostly 70% of the time is being consumed in verification rather than design. Because a single bug or a single defect within the design, be it your smartphone or laptop, smartwatches or anything, not only derail the entire project execution lifecycle, but also slipped the product timeline to meet the time to market. And due to that, to catch those bugs, large number of test scenarios needs to be coded, and which are actually huge in number. And due to that, if automation is not bring into practice, it will eat up a lot of time. So here, machine learning based models, along with neural networks, which is like a subset of artificial intelligence, can help. With the help of this artificial intelligence, we can train a model such a way that it can depict the correct scenarios, saves a lot of time, and able to pinpoint the bugs in the design, so that the product can be shipped into the market quite swiftly and easily. One more area where artificial intelligence is nowadays playing a key role is in the EDA tool optimization. So what is an EDA tool? So basically electronic design automation, which are useful for simulating the chip or verifying the chip. Nowadays, the vendors are coming up with ML-based engines inbuilt within it to catch the bugs faster and to ship the product more swiftly than the stipulated time. One more key area where artificial intelligence is playing a key role is in image signal processing. So let's say nowadays, with your smartphone, if you are clicking a picture, that picture is coming up with superior qualities because of this integrated framework of artificial intelligence and semiconductor. Because the blur has been corrected, the noise within the image has also been corrected, and the image curve has been smoothed out with the help of these machine learning algorithms. One more area is that within the field of design it has been used in semiconductor, is that artificial intelligence is very much frequently able to analyze the past designs, or let's say the legacy designs, so to say, and able to come up with better optimization technique in the power, performance, and area. So whenever the newer smartphone being released, they are coming up with an update, let's say with the camera or with the display qualities, because of this analyzing capability of the artificial intelligence of the past designs. So we can clearly notice that artificial intelligence as semiconductor is already reshaping our future. And if we are able to integrate multiple technologies together, it not only gives birth to newer innovations, but we can merge the advantage of one technology into another as well. But there is a downside to it. There is a problem with this ever-increasing amount of innovation. Because specifically, technologies like artificial intelligence, if not controlled properly, it might be possible in the future that it might be limited to certain sections of people. Because over a period of time, it might get expensive as well. Moreover, due to excessive use of generative AI models and the LLMs, the hardware resources like GPUs are frequently getting overheated and needed tons of water resources to cool it down, which is again very costly in terms of environmental conditions. Moreover, there are research also going on that artificial intelligence over a period of time, which are calling it now as an artificial narrow intelligence, will gain the human consciousness and might achieve artificial general intelligence. So there needs some technology which can control all these factors and make sure that the AI can be democratized and reach all the sections of people. Moreover, this technology can also increase the efficiency of the semiconductor devices by improving the infrastructure through which the codes or the product has been shipped into the market. So this particular technology is called as blockchain, which thrives on the idea of decentralization. Before I move with decentralization, we need to know how it arrived and what are its different use cases. Back in the year 1990s, when internet was invented, a person can only be able to view an internet page. Like, he can't write anything onto that, he can't comment onto that. That person has only reading permission. That phase is called as a Web 1.0 phase or reading phase. After that, we have social media apps like YouTube, LinkedIn, Facebook, Instagram, where a person can interact with the other person, or so to say in the web page, in the form of likes, comments, and shares. That phase is called as a Web 2.0 phase or reading and writing phase. After that, a new web technology arrived, which completely changes the landscape of web technologies because it addresses a problem which Web 1.0 and Web 2.0 are unable to solve. And that is called as an ownership. With ownership comes transparency. So in that case, blockchain is like kind of a technology which is of like a superset in this decentralized network. So what does actually blockchain mean? Blockchain is an interconnected networks of peer-to-peer which are connected securely over the network, and the most fascinating part here is that there is no central authority. No one is the owner of that particular network. Let's say I have 10 nodes in a network who are connected together from 1 to 10. So all these 1 to 10 nodes are the owners of themselves. There is no governing authority. And let's say if I want to push any innovative use case onto that network or any transaction into that network, the majority of the people out of these 10 nodes has to say yes. That is, out of 10, 6 people needs to agree with the other people that this feature needs to be carried out into the network. And that feature is called as a consensus mechanism, or like you can say kind of an agreement. Blockchain, like AI, has also disrupted multiple industries. Like real estate sector has been revolutionized because let's say you are going to rent out a house. So you need to be enter into an agreement with a tenant. So there is an agreement with a tenant and the owner in the term of a physical contract, or let's say agreement. Now this has been replaced with something called as a smart contract. So smart contract is something similar to a physical contract, but it's been written in the form of a code and been pushed into the blockchain. So what is the advantage of that? The advantage is that once it got pushed into the blockchain, it's open source, but it's not modifiable at all. That is, it is tamper-proof. No one can able to modify it. And due to that, both the tenant and the owner needs to abide by that rules. Moreover, cross-border payments has been eased out because of the use of the blockchain, because there is no central authority, and the transaction fees are also getting lower, and the processing part is also getting fast. Supply chain management is also impacted due to blockchain, because now from the source to destination, each and every process has been tracked and traceable. So that let's say you are going for any courier delivery or through the interconnected blockchain network, then in that case, each and every process has been tracked. It's also helpful for the environmental condition, because nowadays carbon footprints has also been reduced because of that, and we are using a term which has been useful for us, that is called as a carbon footprint negative. So the next question comes, how we can leverage this blockchain for artificial intelligence or increase the efficiency of the semiconductor devices. So in case of artificial intelligence, we can use public blockchain integrated with smart contract. So what it does, public blockchain is a type of a blockchain which are open source and like transparent, completely transparent. So with the help of public blockchain, smart contracts, which is like kind of an, as I explained earlier, is a code form of a physical contract, has been integrated and been captured into a decentralized application where there is no owner. So it will make sure that artificial intelligence has been democratized and will be reaching to all sections of people. Moreover, if I want to set the same thing or set the same framework for the semiconductor devices, it might not be possible. Because while doing a project, confidentiality and privacy is a factor. So due to that, I need to move with other form of the blockchain, which is called as a permission blockchain. With permission blockchain like Hyperledger Fabric, which has already been used in the industry by enterprise application, it will ensure that only a limited number of people can interact with the network. Let's say, as I have given the earlier example of 10 nodes in a connected network, in the 10 nodes, each of them are the owners, but let's say out of these 10 nodes, only 7 people who are working on the project diligently should get access to the network. So that will be assured by the framework called as a Hyperledger Fabric on the basis of something called as a certificate authority. Certificate authority ensures that only those many number of people should get access to the network and the others should not get any access to the network because privacy is concerned. Now the main point here is that with the help of Hyperledger Fabric, more number of engineers can work collaboratively with each other without any interdependency on the other engineers. They can push newer innovations into the code database and also able to ship the product much more swiftly because they are working collaboratively on a single goal. So here we can see how integrated technology has a positive impact on our society, and technologies like AI, semiconductor, and blockchain each has their own individual use cases. But when they are integrated together, they open the door for multiple innovation. So last but not the least, I want to end the talk with a simple thought. One technology is not sufficient to bring all the innovations. And if we really care about our society, we need to immerse ourselves in imagination, push the boundaries of innovation, and more importantly, connect the dots properly so that we can bring a positive impact into the society and make this world a better place to live in. Thank you.